All right, so today what we're looking at are some other types of non-traditional inheritance in terms of, last time we looked at um, codominance and incomplete dominance. Today we're going to look at polygenic traits, which we can't really do crosses for, multiple alleles, and sex-linked crosses. So we're going to start off with the one that we won't be doing any crosses with, and that's polygenic traits. Now that's not to say that we can't do crosses with them, but we usually don't. Excuse me. Polygenic trait refers to the fact that some of our traits are determined by several genes and not a single gene. In fact, one of the examples that we tend to use all of the time with dominant and recessive is eye color, and eye color is actually an example of a polygenic trait. If I look at two people who have brown eyes, they don't have the exact same color of brown. So that's part of the reason why that is a polygenic trait. So it is difficult to determine the probability with polygenic traits, and like I said, I give you the example of eye color. And so here is actually an example of this. We have two genes determining eye color, and so you get all of these possible different combinations with this. So that's why we don't tend to do it, because once you even get beyond, you can actually have 3 or maybe even 4, and it makes it really, really difficult. Another type of polygenic trait is actually height, and you can actually see this here. They lined up by height in inches, and we form this bell-shaped curve. Okay. Other polygenic traits include things like skin color, sizes of different body parts, like the length of your arms and legs, shape, or even your weight. And you can actually see down here, with one gene we get 3 phenotypes, the dominant, the heterozygote, and then the recessive. With 2 genes, 3 genes, and then many genes. So more genes that are involved, actually we get the smoothing of the curve with that. Okay. So the second one that we want to talk about today is the multiple alleles, and we will be doing some practice with this. Multiple alleles are when we have more than 2 alleles that code for it. So instead of just one dominant and one recessive, we might have another one thrown in there. And a great example of that is our blood type. We have 3 alleles for the blood type. Type A, which is dominant, so it's a capital I with A. Type B, which is a capital I with a B. And then lowercase I, which is type O. So this is what happens. If you look at someone that is type A, okay, they have the A protein on the surface of their red blood cells. So they can be either homozygous dominant with type A, or they can be heterozygous because they can have that O gene that will get overpowered. Type B has that B protein on the surface, so again, they can be homozygous dominant for type B, or they can be heterozygous. O down here on the end, the only way you can get it is with the homozygous recessive. Now, if you have the heterozygote of type A and B, this is actually codominance, so there's no blending, and you will see both A and B. All right, the last one. If you take a look here, do you see some numbers? You should on the left see the number 8, and on the right you should see the number 6. But people who are colorblind actually have a problem with this. And colorblindness is a type of sex-linked trait. So some of the genes that we have in our bodies are actually linked to the sex chromosomes, which are chromosomes numbers pair 23. So those are our X and our Y chromosomes. Many of these are what we call X-linked. So the gene appears on the X chromosome and they are recessive. And what happens is, if you're a female, that means you need to have 2 bad copies of the gene to get the whatever condition it is. If you're a male, though, you sometimes only need 1 because the Y chromosome is actually smaller, and sometimes there's not a partner that can actually have a normal gene to overpower the bad one. However, we do have a few that are Y-linked. So as a result, like I said, males tend to show these traits more frequently than females because they only need 1 allele. In order for a female to get this, we need 2, and colorblindness is a perfect example of this. So a lot of times what ends up happening is mom ends up being the carrier. Okay, so she is actually carrying that defective gene, which, she doesn't show that she has the problem. And she can pass that on to her daughter, but because dad's not affected, she's fine. Because dad gives her an X and mom gives her an X. But what can happen is mom can only give an X. She can give the defective gene to a son, and if dad is giving a Y, then the son will be affected. So some examples of things that are X-linked are things like color blindness, hemophilia, and Duchenne's muscular dystrophy, which is a muscular disease where the muscles waste away. For Y-linked, we have hairy pinnae, which is where hair comes out of your ears and nose, sorry guys, and baldness are linked to the Y chromosome. All right, so in your handout packet, we actually want to get you over to this worksheet, multiple alleles and sex-linked crosses. And I am just going to zoom in a little bit more. All right, pop this up. There we go. And just scoot this down. Okay, so we're going to do the first one together. Tom P. Son faces charges in a paternity suit brought by Mary H. Lamb. Tom is blood type AB, while Ms. Lamb is type O. The child has type O blood. Could Tom be the father? So you have to explain using crosses. All right. So Tom is type AB blood. Okay, so we know that that means he has type A gene and a type E gene. Mary is type O. So the only way she can do that is to be recessive. So now we're going to do the Punnett square for this. We're going to put Tom across the top and Mary across the side. And then we're going to fill in. Now, let's take a look here. For these two possibilities, this is type A, and for these two possibilities, this is type B. Those are the only possibilities that could happen if Tom and Mary were to have a child. So if the child is type O blood, there is no way that Tom is the father. So there are two more problems that deal with blood type, but hopefully that gives you kind of a start to kind of see. We don't always have to go through the 5-step process with this. All right, flip this over to the back. Oops. Sorry. All right, and we're going to deal with the hemophilia. Hemophilia is an X-linked trait. If a carrier, heterozygous female, has offspring with a hemophiliac male, what is the ratio of offspring produced? So we're dealing with sex-linked here. So we know we're dealing with X and Y. So hemophilia is X-linked. If she's heterozygous, she's going to have one normal X and one that carries the hemophilia gene. Okay. The male is hemophiliac, so his X has the hemophilia and then the Y. So again, we have to do a Punnett square and do the cross. So we have X. So we're going to have this. All right, so we've got 25% here. Carrier female, because she has a normal one normal that overpowers the bad one. We have a 25% chance of a normal male. 25% chance of a hemophiliac. female, and a 25% chance of a hemophiliac male. Okay. So what I want you to do is I actually want you to try those additional problems, and then you can come check your answers. Please make sure that you come and ask me if you have any questions on this whatsoever.